So we're going to solve quadratic-like equations. What we mean by that is they're in quadratic type form, but they're not actually quadratics. The exponents are a little different. The key here is whatever the first variable is, exponent is, it has to be exactly double that of the second mention of the variable. So our first example, let me show you what I mean. It's going to be x to the fourth power minus 5x squared plus 4 equals 0. Now, note the exponent on the middle, x, is exactly half that of the other one. That means it's quadratic-like, and we're going to see that theme throughout all of these examples. First off, I'm going to take a minute, and I'm going to drop it into a quadratic equation, and I'm going to let u, just some random variable, I picked u, equal x squared. And please note that x to the fourth power is actually equal to x squared squared. So if u is equal to x squared, then when I rewrite my equation here, I'm going to actually get u squared minus 5u plus 4 equals 0. Now this is something I can get into because I recognize this. So I'm going to go ahead and factor this using whatever method your teacher taught you or that you learned how to do. That's going to give me u minus 4 times u minus 1. And I'm going to set each piece equal to that. So u minus 4 equals 0, which means u equals 4. And u minus 1 equals 0, which means u equals 1. Now remember, I'm not solving for u, I'm solving for x. So I'm going to rewrite u equals 4 as x squared equals 4. X squared equals 1. Now I learned how to solve these, and I'm going to go ahead and take the square root of both sides. Don't forget the plus or minus, which means x is equal to plus or minus 2. Now that's two answers, that's not one answer. That's positive 2 and negative 2. Next up, x squared equals 1, which means x equals plus or minus square root of 1, or x equals plus or minus 1. I actually have four answers here. I have x equals negative 2, negative 1, 1, and 2. Four separate answers. By the way, if you're wondering if there's a connection between the original problem has x to the fourth and there are four answers, there is a connection there. You'll learn that at a higher level mathematics class. Next example. So I have 4, this one's really going to be weird, times 2v plus 1 squared minus 16 times 2v plus 1 plus 15 equals 0. Now, this one really is funky. So I'm gonna notice that I have the parentheses, the 2v plus 1 squared, as well as the 2v plus 1 in the middle. The exponent is still double that of the other. So off to the side, I'm going to say that I'm going to let u equal 2v plus 1. Which means I get to rewrite this as 4u squared minus 16u. By the way, you don't have to use the u. You can just go, if you see it, then you can just go as it is, plus 15. I think most students prefer to see something that they're familiar with. I'm going to go ahead and factor this. Now, if I couldn't factor this, I could use the quadratic equation on this as well. Either way, it's going to factor into 2u minus 3, again, using whatever factoring method your teacher taught you, times 2u minus 5 equals 0. Now I'm going to set each piece equal to 0. Solving for u, I get u equals 3 halves. And the other one is going to give me that u equals 5 halves. Now remember, u is equal to 2v plus 1, so I got to go back to the original. Now solving for this, I'm going to subtract a 1 to both sides. That's going to give me 2u 2v, pardon me, is equal to 1/2. Got to get a common denominator. And now I'm going to divide both sides by 2, which is going to give me v equals 1/4. There's one of my answers. Here I have u, which is 2v plus 1, equals 5/2. And I'm going to solve for v, so I'm going to subtract 1, get a common denominator. That gives me 2v equals 3/2. And dividing by 2 or multiplying by 1/2, either way, is going to give me that v is equal to 3/4. There are my two answers. You always have to go back to the original variable. Next example. I'm going to have x to the 2/5 power plus x to the 1/5 minus 6 equals 0. Now again, notice the first variable, the x to the 2/5, is exactly double the exponent of the other one, x to the 1/5. So I can rewrite it like this, just to help me kind of visualize that a little bit better. So what I'm going to do is I'm going to so x to the 1/5, let me finish writing this out. So I'm going to go ahead and let u be the x to the 1/5. So my equation becomes u squared plus u minus 6 equals 0. Again, I can use the quadratic formula if I want. Again, this one's nicely factored. U plus 3, u minus 2. Set each piece equal to 0. Gives me u equals negative 3 and positive 2. But again, I have to go back to the original variable, which is u is x to the 1/5 power. And that is going to give me, when I solve that, I'm going to raise both sides to the 5th power. And that's going to give me x equals negative 243. That's negative 3 times negative 3 5 times. So there's one answer. Next up, I have x to the 1/5 power is equal to 2. Again, I'm going to raise both sides to the 5th power. Which means x is also equal to 32. There are my two answers. Last up. So we have another weird case here. We have 10z to the negative 2nd power minus 3z to the negative 1st power minus 1 equals 0. Again, notice z to the negative 2 power is exactly double the exponent of z to the negative 1st power. Write it in this notation, it's a little bit easier to see. There we go. And now I'm going to let u be, you guessed it, z to the negative 1st power. So changing my equation, I now have 10u squared minus 3u minus 1 equals 0. And I'm going to go ahead and factor it. 5u plus 1, 2u minus 1. Again, you could use the quadratic formula. That would work as well. Just be careful that you transform it all the way back to z. Setting each piece equal to 0. U gives me negative 1/5, which when I transform that back, let me go ahead and solve for this side here. U is also equal to 1/2. Now I got to go back to z. So instead of u equals negative 1/5, I'm going to get that z to the negative 1st power equals negative 1/5. And I'm going to rewrite that as z to the negative 1/1 power is the same thing as 1 over z equals negative 1/5 power. I'm going to go ahead and flip both sides, or cross multiply, however you want to view it. That gives me that z is equal to negative 5. On the other side, again, u becomes z to the negative first power, equals a half. I'm going to rewrite it as 1 over z equals 1 half. And I'm going to cross multiply or flip both to give me z equals 2. And there are my two answers.